Okay, our next proof says the triangle congruence theorems can be used to prove many other theorems. Bearing this in mind, construct a proof for the following theorem. An isosceles trapezoid has congruent diagonals. So the hint is you're going to use triangle congruence theorems. We need to draw an isosceles trapezoid first because you need to have a figure to work with. We're going to call this A, B, C, D. It's isosceles, so you know that not only are these two sides congruent, but these two sides are equal. That's the definition. The fact that these base angles will be equal to each other, that's a property that follows. So that's important to bear in mind. Now, you want to prove that their diagonals are congruent. As soon as you do that, you see you're splitting it up into triangles, and that tells you, hey, just use triangle congruence theorem. Show that this triangle right here is congruent to this triangle right here, and then by corresponding parts of congruent triangles, these two lines, the diagonals will be congruent, thus proving that for any isosceles triangle, the diagonals are congruent. That's what we're going to do. We're going to do this by what? Well, we already know that these two sides are equal. This side repeats. These base angles are equal because, why? Because that's a property of an isosceles triangle. So we're going to use good old side angle side. So we're given that A, B, C, D is an isosceles trapezoid. And what do we want to prove? We want to prove that AC is congruent to BD. So we start out with our given that A, B, C, D is an isosceles trapezoid. So that's a given. Our second thing, AD is congruent to BC. That follows from the definition of an isosceles trapezoid. The property that follows from an isosceles trapezoid is that ADC, angle ADC, is congruent to angle BCD, and that's because base angles of isosceles trapezoids are congruent. We know that DC is congruent to itself by the reflexive property. We know that triangle ADC is congruent to triangle BCD by side angle side. And therefore, by corresponding parts of congruent triangles, we know that AC is congruent to BD, which is in fact the diagonals. So we have proven that theorem using triangle congruence theorems.